Hello, I'm Joseph. Today I want to show you a little bit of a prototype, but a game engine all the less, specifically designed for dynamic languages, specifically designed for what I've gone through with PHP, writing native extensions for PHP. So this version is just a bunny benchmark. Pretty simple. You can see I've run two different commands, and this is important, but this is the bunny benchmark. You just throw up a bunch of bunnies. I can go up to 50,000 sprites before I just kind of give up because the frame rate's too low. PHP is running in a single thread system, NTS, non-thread safe. So you're going to get a little bit of degradation with this here, but this is actually two separate processes talking to each other via IPC. This is important because this will enable you to use live reload in the PHP CLI. This way you don't have to have any special embedded version with PHP to get live reload to work. And you can use any version of PHP as long as the DLL is compiled for it. And this supports non-thread safe and thread safe variants of PHP itself because it doesn't matter. It's simply the IPC communication that works on Windows, Linux, and Mac. But this is the dev version effectively. And if I press the letter D, it swaps from PHP to using the native code to do the positions. I'm not quite sure. I got to relook at the bunny code here as to why the offset's different from the PHP versus native, but you can see I get much better performance out of that. And the backend code to this is in Swift. And if you don't know, this is running on Windows, and specifically Windows on ARM. So there's no support for Windows on ARM with the official PHP releases. I'm using experimental branch or a release. And Swift does support Windows on ARM, so I can get native support out of that, and it's very performant. You have one of the reasons I've chosen Swift for the backend native code is first, it's a lot easier to learn than C or C++ or Zig or Rust. It has concurrency and parallelism built in, but also with strict concurrency flags turned on for compiling, you get things like data race conditions checks. You get the checking to see if, like, if you tried to access data that was on the main thread, but you're in a separate thread or some asynchronous task, it's not going to just let you access that. You need specific properties or mechanisms to access that properly. And so it's just a really safe way to do all this stuff here. Now, this is all still very basic things, but this is the client server variant, the development workflow that you could expect. What I'm going to show here next is that same exact engine, but running in a DLL that is loaded into the PHP CLL at runtime. So I have the Phorst engine.dll, and it's just, a regular PHP extension, and it's the same thing that as before. It's all the same engine backend. So if I can load this up to 50, instead of 7 frames a second, I get about 8 frames a second, 8 to 9. It's no, it's not really that much of a degradation loss of performance over the IPC client server configuration. And if I press the letter D, you can see it switches back to the native code again there as well. So I'm going to go a little bit more into this as well to talk about a little bit more of the backend stuff, but you can see that I've written a native extension for PHP with Swift as well. Talk a little bit more about that, I actually have the entry point for the DLL defined in Swift that is exposed as CAPI that is MSVC CABI compatible. It's a lot of terms being thrown right now, but effectively, you can't just compile any DLL any way you want. It needs to be CAPI compatible. There's only two available for Windows, which I believe is the GNU and MSVC. Was basically like if I compile something and I need to use a Windows service that has a DLL attached to it, I have to target MSVC. And so php.exe is targeted with MSVC, and I'm doing that with Swift as well. Now, you can use any compiler to target to any CABI, and I want to digress a little bit here, but basically, as long as you get the same CABIs, it should be mostly okay. So get module is the entry point in the DLL that's like basically the C function, and it provides and builds out everything it needs to properly load into thread safe and non-thread safe variants of the DLL. That's if you want to go this route. You don't have to you can do the IPC route, which means you don't even need a DLL to load into this. You can use a completely separate PHP, any PHP version you want that supports IPC and can work with the event system or the pack and unpack features that PHP provides with, I think it's PHP 7 and up. So you can forego having the need to ever maintain a plugin or an extension, native PHP extension for PHP, just by going through the IPC route, at least for development. Packaging will be different. Now, this hasn't been a simple process. I'm going to be honest about that because PHP CAPI is mostly C macros. If you don't know what that is, that's glorified string replacements that do not work in any other programming language other than C and C++, which means I've gone through and go ahead and converted many of the macros I need to do my work currently for this stuff here. And so some of these are a few hundred, some of them are a dozen, some of them are 1,000 lines plus for how all this stuff works. This includes argument parsing, all this other stuff. I have a separate project I have made that has that allows you to use Swift to make native PHP extensions for Windows, Linux, and Mac. So that is something to think about there. Now, this hasn't also been an easy process either. Because Swift does not use the MSVC compiler to compile with Swift code, optimizations in release mode become problematic. One case in point here that I do need to point out is when I look for string init fast here, I had to switch to the fast function because zen string init with the 0 value marked will pre-optimize into a function that is generated through the Clang toolchain that MSVC's toolchain will not optimize for. So by using the Zen string init fast, it's a sub function. It's a function that wraps around the Zen string init that prevents the Swift compiler from optimizing this code out at compile time. So there's some minor things in there where there's going to be problems in at least in release mode compiling your Swift code if you wanted to target the PHP integration route, which is going to be obvious down the line. And I've only shown you 2 ways you can interact with this engine. The third I have not done yet, at least redone yet. Okay, so enough about the PHP side of stuff with Swift and getting this all to go together. I want to talk about the next major part here, which this is an event-driven system. This is most best kind of shown with the main.php, and effectively I have a very, very small surface I actually integrate with Swift and PHP as a DLL, and it is a couple functions. So Phorst update is one that you implement, but you grab the event blob, which is just a string, and you return a string. You're like, hey, what? Aren't you supposed to be returning like a class or state or something? This is not just event driven, but it's a separate world between the client and the server, the DLL, your PHP code, and the native DLL code in Swift, meaning that live reload will definitely be possible. Because you can then drop out your client code and via an await and sleep, you can serialize and unserialize as you need to bring back your state of your script code, but the engine will still have every single sprite that you had created on the PHP side. It's still available in the engine, and it does not need a awake or sleep variant of that because it will continue to run as your code updates. So, but this means that this is all binary packed C structs. And these are all fixed with a few dynamic ones for example example loading in order to support UTF-8 file paths and other stuff like that. I have just a way that you can put in any size length of a path because I know there are limitations on paths for Windows, Linux, Mac. But yeah, you should be able to load up any texture path that you want, and it'll work. There is a function here that will go ahead and take that string and explode it out into events. And now you'll be saying, why just do a string? Why make this so complicated? Can't you just do PHP arrays? That's another surface of integration you're going to have to do on both sides. But more to the point, it's actually faster to pack and unpack strings into PHP arrays than it is to pass PHP arrays and generate them on the server side, the native side of code via Swift, and the PHP side of code as well, which is a little bit of an odd thing to think about, but yeah, that's just the reality of it. Also, PHP arrays are always copied when you're passing them into functions, so that's going to give you a little bit of a performance hit as well with that. I will say that if you create 1,000 sprites, you will be packing 1,000 events, so you'll be calling pack 1,000 times. I've tried to chunk in bulk pack stuff, which gives a great performance boost. Unfortunately, in order to implement that in a way that's usable, it's less performant then because it has to do it has to store the information before it can do chunked or bulk packing. Um, Now, you might not be sure, like, what does that even mean? And that's more to the point, like, it's intentionally hidden from you as a programmer. So, for example, this is the window class. It takes in a title, width and height, and then you can set flags here. This is all completely invisible to you until you want to say, okay, I've done my window updates. I need to go ahead and then call, pack dirty events and pass in the packer, which then does all the legwork for you to, like, okay, you set this to resizable. You gave it a string, you give it a width and height. Let's go ahead and put these all into events, into a string, add it to the packer, and then the packer finalize generates the final string and sends it into Phorst run, which is a infinite loop that runs into the Swift backend. Um, if you're more interested into learning what this is even packing, like how does the pack format work, it's via the PHP pack format. So if I go into Phorst update here, you can see the various events here. So that whole window title, resize, and flags as an API are actually just triggered events with numbers attached to it. And then the individual pack formats for resize, title, and flags, these are all done via the PHP pack in unpack format. So you can pack these as into an array and as an array, and it uses vice versa. And then there's some bit of padding here, which I'll get into in a little bit. But you can see I'm tracking inputs and sprites and all the actions you can do with sprites. And this will, get built out over time more and more as I add in collision detection or physics engines and GUIs and other stuff like that. Now, this does create a little bit of a problem, at least for the PHP side, because when you pack a C compatible C structure into a blob or a string or just an array of bytes, it tries to be efficient in how it manages that to be able to pack and unpack that in your native language. So in Swift, it's actually pretty easy. So if I go to my Phorst section here and I go to one of the events here, like mouse button events, this is all it looks like. And you can see that I have X, Y button and clicks with a padding here. The padding is intentional. Any set of values that you have in your event to be packed has to be divisible by 4 to a certain extent. And then after it hits a threshold, it then needs to be divisible by 8. And so by adding padding into certain events, you circumvent an issue that will crop up when you're dealing with packing C structures, which is it will add padding in places that you may not think about. While if you intentionally add the padding yourself to make it hit that divisible mark, it's fine. But if you don't, what will happen here, if I go back to my Phorst with the events here, is the sprite add was actually 124 bytes packed in PHP, but it was crashing the server because the pack format was wrong because it was adding padding. It had to be expanded out to 128 bytes, which is what Swift would do when you packed in a sprite add event. And it didn't add the padding at the end, which is why you saw the padding added at the end of the other structs there. It added it in between the color and the speed of the sprite when it's initialized. Um, you don't really want to do this. You don't want to guess where padding is or try to do complex or not complex, but just the rigorous testing to make sure that the padding that you add in between all this stuff is correct. And it could be machine dependent. You don't know. So it's nicer to have the padding added to the actual C structure, or in this instance, Swift C structure, to be utilized and leveraged. This does mean that if I generate a C header with these pack formats, that you can use any language to interact with this game engine. You can use Zig, Rust, Nim, C, C++, Dart, .NET, C Sharp, F Sharp, Java, Kotlin, all these that can interact by working with packed binary data and unpacking it via C structs like that, which is really cool. It's not really PHP specific, but I designed this around the limitations I found when working with PHP itself. Now you may be considering, like, okay, why even work with a DLL? Why not just go with the IPC route and other stuff like that? If you want to ship your game, it's obviously not beneficial for you to have a client server set up, because then you have to orchestrate this when you're running your engine and stuff like that. That's not ideal. But more to the point, PHP does have JIT and other stuff that it will run that will be helpful when it's just a php.exe that you can just ship with your game. But there is another point that I will get to, which is that this is not the end goal. It is to have a .exe, .app, or just a binary for Linux packaged that you can ship your PHP game with. This is not intended to be a DLL. This is not intended to be an IPC client server. And I've already demoed this actually last year in a video about embedding PHP into Swift, so that you can make a binary and actually package your game that way. So there is an end goal that is greater, and I can get this to iOS. I can get this to Android. Android is a bit more problematic in that, in my previous experience, you have to customize the PHP source code so that you can interject things that the the Android runtime requires in order to load a file from your APK and stuff like that. So um, this is, just a first step into many things, but an exciting one for me, because I'm getting to a point where I'm not dependent on making an extension if I don't need to. And by making a DLL, I can repurpose all that when I embed PHP into Swift again, and then I can just use the extension code that I had generated here to go ahead and work with all this here. Now, this unfortunately is not available yet. I need to finesse and fine tune and clean up stuff that makes this available for Windows, macOS, and Linux. This will not have the unfortunate executable packing feature, which is, should be able to ship your game, but just lets you be able to at least work and test around game logic in PHP this way. If you didn't want to learn a new language, you don't have to. And if it's just something you want to mess around with, you can. But yeah, so this is the Phorst engine programmed in Swift with helpers in PHP.